and welcome to another episode of the Kilted Filker Workshop, where today we are going to be talking about all things Siege, Siege engines, and how to optimize your Siege engine design for live combat. For those of you who make your Siege engines for demonstration purposes or historical purposes, this might not apply to you, but if you are in any kind of combat with your Siege engine, whether it be for the SCA or another LARP or some other organization, this is going to apply to you because we're going to talk first about the three main principles that are in conflict with each other, but you need to balance as you build your engine. Then we are going to talk about specifically for the Arbalest, the Docmo Kincaid design, some tactical changes and ways that you can optimize this for those 3 points. Then we're going to head in the trailer and talk about the big gun, my Roman Torsion Ballista, and how I apply those 3 principles in designing that and some future changes that may be coming depending on my time and the weather. So, the 3 principles that you need to really care about and think about as you build your Siege engine, first is power, right? And by power, what we're effectively saying is, what's the range of this engine going to be? In SCA combat, your Siege engine must be able to shoot one of the siege bolts a minimum of 40 yards, but a maximum of 80 yards when at a 45 degree. Not going to necessarily get into the why, but those are the rules. The second point of this is usability. Not only how easy is it to use that engine, but fatigue. Fatigue certainly becomes a factor that we'll talk about in a second. And then the third point is firing rate. And by firing rate, I mean how often are you able to fire, reload, and fire again, getting your ordnance downstream, whether you care about accuracy or not. Because often just getting that siege bolt within the vicinity of your opponents is disruptive. Other times, obviously, you want to, well, not kill them for real, but hit them so then they die within your game. Now, the problem with power is that power affects your firing rate and your usability. If I take a siege engine and I tune it for the maximum power setting, that's good because now if I can outrange or outgun another siege engine, I'm able to kill him while that siege engine is not able to kill me. But also I can hit targets farther away, in theory. However, the trade-off with that is, one, if you are shooting for someone at 75 to 80 yards, wind becomes a huge factor, right? So your accuracy is going down, but then on the usability, there's 2 key areas. The first is that someone who is weaker, someone who does not have the body strength, will not be able to, in some cases, pull that engine back and cock it all the way. This is something that I've seen when we've brought these 2 engines to demos, when we've had events even just within the SCA where various people can come up as we've started to do target shooting. There are some folks that have struggled, especially within the last inch or 2 of these 2 engines to get them pulled back. But the second issue with a more powerful engine becomes fatigue. At Pentic 50, we had bridge battles that were 15 minutes long and had a very nice break in between. In those battles, fatigue did not become an issue. But at Pentic 51, we had 60-minute rounds without any breaks unless there was some sort of hold for medical or whatever reason. So fatigue became a big problem, and the more powerful the engine you have, right, the more fatigue you are going to have, and potentially you're going to limit the people who can actually use your machine. But then on the usability side, by usability, I'm not just talking, do you lower the power so that somebody is able to use it? What I'm talking about is the actual design, and I'll talk about this engine here, which is the first one that I made. I made it for me, to be used by me. I did not know at the time if I would be building any others, and so I designed this for my body. And so when I looked at the width of these handles, right, I looked at my shoulders. One of the things that I also found are either younger engineers or smaller engineers, women, whatever, had some trouble even reaching the handles. But I also made the handles long enough so that I could crank this forward and backwards with relative comfort. I also made the neck so that this was at a comfortable position for me. So just from a usability point of view, you want to make the engine so it's usable for the people who are going to use it. And if you don't know who the people are, then you might have to make some trade-offs. Some of the trade-offs that I made were, for example, the length of these arms, knowing that the longer arms would make it easier to pull back on the bow. Also, I made the spinnable handles so that my hands could grip tightly and this would operate smoother. So, the third point, talking about rate of fire. The big issue, and especially with these Docmos, and I'm going to talk about something that I observed at both Pennsic 50 and 51, where there were probably about 13 to 20 engines there built by different builders. Some of the engines had actual ratchets back here, right? And so I'm watching on film and I'm watching during inspections, and the person who's cranking it back, literally, wee, and I could go on and make some jokes about that, and it made it very easier for them to use, but the rate of fire was extremely low. Versus on my engines, on this, the difference in the cranks between these two, this one's got 1-inch pipe, this one's got 3/4 inch pipe. Because this one's got a bigger diameter, it takes less time to pull back, but also makes it slightly harder to pull back. This engine, having a slightly smaller diameter, it'll take a couple of extra turns, which again takes a little bit of time, but also makes it easier. One other difference between these two engines is that the prod on this engine is 2 inches further than the prod on this engine. This engine is currently tuned for about 60 to 65 yards. This engine is tuned for 75 to 80. And so I've seen differences with people's ability to use these engines. One of the other problems with too much power is you need to tune or design your engine for in some cases, the scenario. When we're talking about a bridge battle, we were shocked because for many of us in the Eastern Kingdom, we had just gotten authorized at Pennsic 50. And I had spent a lot of time shooting these, and I was practicing at 30, 40, 60 yards to try to learn some accuracy and build that muscle memory. But at that first bridge battle, we were at maybe 20, right? 30 yards at best from our targets. And so the more powerful gun, this one, actually had a hard time hitting its targets because the slight difference in angle, because of the power of this gun, was the difference between hitting someone in the chest and going 3 feet above their head. However, as a side note, some of what got back to us near the end of the bridge battles were some of the bolts from this gun were making it into the backfield of the mid-realm and agitating their staff and their fighters. And I questioned the marshal saying, are you telling me this to try to stop us from doing this or to encourage it? And of course the marshal had a good laugh and we continued. But so for us, this gun was far easier to use in that first bridge battle. But then on the back to Pennsic Friday, when we got to the field battles where people were literally on the other side of the massive field, range was a factor. So it's that trade-off, right? And what do you decide to do? Do you make your guns so they're really good at intermediate ranges like this one is? Or do you make your guns where you're trying to get for long range like this one is? And does it matter, and what are the trade-offs? So let's talk about what you can do on these engines specifically to adjust those two parameters. On these engines, so first let's talk about power. As I mentioned, this one is tuned for 80, this one is tuned for 60 to 65. I built this one at 65 by mistake. Looking at the Docmo plans, there's a table in there that talks about the prod and do you have a backer and what range you have, and then gives you a measurement from this point here in the middle of the trigger to the back of the prod hole. Mr. Kincaid, in writing his lovely document, forgot to include the specs for if you just have a single prod and you want to get to 75 yards. So we were at an event prior to Penzig 50 where somebody else had brought his siege engine. We're both hitting the same chair, which we measured at about 60 yards, except that my bolts had a very high angle and his bolts flew pretty flat. I then took a tape measure and went, hey, do you mind if I check it out? And lo and behold, his prod hole was 2 inches longer. And so I had cut the wood for this, but I hadn't finished it. So I simply extended both holes. And as a result, on this one, I can actually tune it to be identical to this one. So if you're doing something like siege bowling or siege skee ball or some sort of competitive event where you're side by side, I could have these the same. So one way that you can increase power or adjust power is by either moving the hole itself, or there are blocks and shims in here that you can sort of tune where the prod is, right? So basically the prod distance to the trigger is one way. The other way is in the bowstring itself. As you twist the bowstring, you will get additional yardage. And so, some people like to go with a shorter bowstring, right? Again, when you build your engine, you will need to test it, because if you're shooting at longer than 80 yards, they will either disqualify you or you will have to depower your engine somehow. But for these Docmos, that's how you get power. On the usability front, the first is the ergonomics, which I talked about earlier. And one thing that I will point at is the height of your neck. Because the height of the gun does affect usability, right? Again, I am 5'8", maybe 5'9" if we don't get a haircut. And so for me, standing back here, this is at a good height. I can put this against my chest, I can pull this back, I can then aim this. For a while, I had this taller because I had bigger wheels and actually a longer neck and a different yoke. And so it was more up here, so it was more about my line of sight. Problem was, even though this one I thought would be easier for some of the women to use because it was less powerful, it was too tall for them. And so some of them were coming in at 5 foot, 5'2", and before I lowered, one, got smaller wheels, and then I got a different yoke, this was very hard for some of them to use. So design accordingly, and when you make your height, right, design it for the people who will use it. And that is a combination of both your wheel diameter and then the piece of wood, right? So customizations. Second point, and I'll go back to the winch, is what do you make this out of, right? I've got plastic here and plastic on this one. I've seen where some people have made it out of wood. I've seen it where some people didn't have this at all. I've seen different thicknesses of this. This is just straight black pipe from the hardware store. But what some other teams did is, as I had said earlier, they literally had ratchets from the boat. They had other mechanisms to make it easier. And so again, it's easier, but your firing rate is much slower. So to talk about firing rate, what you can do to increase it, it's really coming down now to your windlass, right? Again, for the same power settings. If you go with a smaller power setting, you have less distance to pull your string. Less distance means quicker, but that might just save you, at least in my design, maybe half a second, maybe a second or two, depending if you're struggling at that last inch to lock it in place. But you can change the diameter of this. A larger diameter, again, means less rotations, but each rotation is going to take more strength. So what I would advise is you do some trial and error, right? You figure out what diameter works best for you and your team. It may be that in the case of 3/4 versus 1 inch, there's really no difference. But that's something that you're going to need to experiment with. But then there are small little tweaks that you can do. One of the things that I did here in the trigger is I took a woman's hairband and I added it to the trigger latch. This way it'll always fall down, so there's one less step for you to have to go. For this guy, and my apologies for the awkwardness, I added simply spacers and duct tape so that this would be pretty close to the stock size to make it easier to push it forward. One of the other things that you can do for usability and rate of fire is practice. Get to know your engine, get to know the movements of your loader, figure out what you can do to optimize those movements. Maybe you should have a third person in your team who is straightening the bolts before they hand them off to the loader, so that way the loader just has to focus on getting the bolt in the engine in the right way and then backing off and then getting the next bolt. Or maybe if you've got a battery of 2 guns, you've got one person who's doing that straightening for both guns. Certainly you can check the straightness of your bolts before the day, but oftentimes that is not an option. And some of the other things that you can do is, for me, not just talking about within combat now, but just in portability. And I'm going to talk about the wheels for a second. I put big wheels on this one, and originally I had the bigger wheels that are on the big gun in the trailer because I wanted to make it easier to roll, right? If I'm going on a field, I didn't want to worry about just the issue with smaller wheels. As it turns out, those wheels were too big. And so I bought smaller ones and then put the bigger wheels on the bigger gun. But on this one, which has got smaller wheels, it's got pneumatic tires. And so that makes it easier when you're talking about bumps. So again, it's about making this something that you and your team are able to use. I can't tell you amongst those 3 points when you're talking power versus usability and fatigue versus rate of fire, what you should do, because every battle scenario is different. Every use of it is different. Looking back on the video from the start of the River Scene battle at Penzic 50, I could see where my gun's firing rate was faster than some of the other, some of our allied guns. And in that battle, firing rate was key because the battle started with Siege hitting targets, and we had to hit all 3 targets before our army could start. And in that case, we actually then defeated the middle because we hit all 3 targets on the second shot from each battery. So in that case, right, firing rate was key. In other battles, it's not. So figure it out. Now, through the magic of video editing, we're going to move. And we are back inside the Siege Mobile. If you're wondering why we are inside a trailer and not outside the trailer, it's simple. She's heavy, and I have yet to install the winch in the front of the trailer so I can then load her and unload her by myself. So that will be arriving tomorrow, and hopefully future videos we will have this outside instead of tucked away here where I can't use it. So let's talk about when I designed this, starting from the scale model that I'll link to at the end of this video, where the scale model was period right. I then had to make a number of changes for this engine to be used in combat. And I'm not going to focus on all of them. I'm just going to focus on the ones around usability and the choices that I made. Well, not just usability, but the power and the fire rate and what I did to optimize all 3. And we're going to start from the front of the engine to the back of the engine. So the structure of the engine is set for a 4-inch hole, but I only loaded rope for a 3-inch hole. That was a design choice I made so that I'm essentially limiting the power of this, because I felt had I put more rope in this, it would become overpowered and too hard to pull back. But the way that you adjust the power in this engine, one is by the rope, right? How much of the rope you have. And two is by how tight I tighten these. So the more I tighten these, the more preload and pretension I have in the ropes, the more power the engine will have. And also, unlike the Docmos which you saw outside, the engine here is variable power. So even for the same settings of the rope, I can pull the trigger at any distance back. So I could make it so these are really powerful and I only have to pull this halfway back, right? Or I can make this a little less powerful and be able to pull it back more for the same power. Again, there are trade-offs. If I make it so this only has to come back halfway, in theory, I can launch quicker. But that's where fatigue comes into play. And knowing that this is limited to 80 yards, when this is finally all complete and tuned up and fully broken in, I want to make it so when it is at the final position back, that is going to be at 80 yards. Also for the arm length, now I did go with the period suggestion of 7x, where x is the size of the hole. If you go with shorter arms, it'll be a little bit more snappy. If you go with longer arms, it'll be easier to pull back, but it won't be as much of a oomph when the ordnance launches. And also from a geometrical point of view, usability now comes into play and transportability. If I made these arms any longer, they would hit the walls. So I went with a compromise and just went with the period right size. Now, let's talk about one of the changes that I made, and that is the slider. This slider itself, in period, would have had a giant dovetail underneath. But because I had to extend the middle of this in order to fit 5 combat bolts, I realized the weight of this would have been significant. So I did what I could to lower the weight, and that's why this is a plank, and I now have effectively the other side of that dovetail on top here with these rails. These rails are not a period design, they just look it, but in this way I can now also adjust left, right, and the pressure up, down. So now this is easier and much lighter and much easier to push up. You'll also notice I added bearings. Clearly, bearings are not period, but it makes it so this is very easy to slide up and down. The usability front, to move more back, in period, these braces would have connected right here. But I added these uprights to give more room so that it's easier to load the ordnance, especially if you're talking about loading the cannonballs versus the 5 bolts. Again, that was pure ergonomics and does not affect the usability of this. But one of the things that I did for safety was I added a ratchet on both sides. Originally, the ratchet was on the outside. But I realize now 2 ratchets means 2 handles. And because I had this in the way, I wanted to have these handles together so they would move as one. Again, usability, quicker to release it, which meant that I had to move these handles and the ratchets on the inside. We'll talk about the gear here, and this is the same effect of the diameter on your Docmos. I actually went through a couple of different sizes to get at a compromise of what I thought would work. So this is just this is an actual go-kart axle with a standard bearing, not a bearing, gear, sorry, connected to a chain, right? Chain is connected to the slider, and you can actually use the axle to move it both ways. So I found a compromise between the force it took to crank this back and the time it took, or how many cranks. Now we need to pause the video for a second because I left a key piece of this in the garage. Ta-da! And we're back. I brought one of these simulated cannonballs just so you can see the scale of this. Had these been connected all the way down and this were all the way back, it would have been hard to get this in place. But that's not what we're talking about right now. What we're talking about are these two arms. For those of you who have had high school physics, right, torque equals force times the distance. So one way to overcome the strength it would take is to have longer arms. And so I made this, and this is the Mark 1's solution. I've got the Mark 2 actually drawn up, and it will completely redo this, but take some of the principles that I learned from this effort. So you put these in place. Now, in my original idea, you would have had one person standing in back doing the cranking. But what we discovered during testing and during combat was you had one person on each side with each arm cranking it forwards and backwards. When the gun is at a high position and you are with the slider all the way up, you can literally spin this. But with the with the engine at a lower angle, what we found was we were actually on our knees cranking it. And I will tell you, it got tiring. Fatigue definitely set in those 60-minute battles where you were literally just cranking the entire time, and your break was when somebody was firing or loading. But the longer arms of this, right, made it easier, and I could go even longer. It's just a matter of finding a longer piece, but also adding something squishy. The fact that we were able to grab this and it compressed a little made it useful. Useful? I don't know, is that a word? But, so from a usability point of view, right, I was concerned about the rate of fire. I was also concerned about range. And one of the things that we did both in practice and in combat is we had tried different angles from 30 to 40 and different positions that we had fired from in order for us to dial in to the position that we were hitting. Now, one advantage of this gun, because it does not rotate left and right, and it does not really rotate up and down, is unlike the Docmos. If you fire this from the same position back, it should be highly accurate, and it was. The feedback that we had gotten from our heavies in the front line was that once we had it dialed in, we were pounding the mid-realm in the middle of their line. I haven't found any video of this yet to confirm it, just going off of what people were saying. So that's pretty much it. There was a lot of engineering work that went into this to make it usable, because the easier something is to use, one, more people will want to use it. Two, with practice, you will get a faster firing rate. And then in theory, maybe I can swap out this gear for a bigger gear if we're able to, say, improve this or update the strength. Or what we might find is when I finally dial in those rope schemes so that this is firing at 80 yards with 5 bolts, we might actually then have to go to a smaller gear. But these are all trade-offs, right? The trade-off with the smaller gear here is that I found that it didn't have enough teeth sometimes connecting to the chain. So I might have to put in some sort of guide to make sure that this tooth, this thing does not slip, which was happening in early testing. And I'm back, because there's one aspect of this that I forgot to talk about that I realized as I went to stop the video. The reason why these come out. I could have made these so that they're permanently connected. But again, this goes to usability and ergonomics. Because with these in the slots, If I now release the lever and try to push this up, you'll notice these arms want to rotate. And so we needed to have a way so that the arms are not connected to the crank, so this will then push up easier, because when I take these out and I then push this up, this now slides up very easy. Also, we were concerned that with the arms sticking in, now as they're spinning, and if somebody is within the range, they're going to get whacked. That did happen. We won't talk about that story. And so what we also found was that at first I was concerned that having to pull these in and out might become a problem. But in some cases, because this has got an axle on it, when we were at 45, if we left them in, somebody could actually hold this in place, and then as these rotated, they would spin. But most of the time, we just pulled them out. And that became part of our procedure in doing this. And then as a cranker, right, you had your ratchet that was configured for your side. You would just pop it in and then start cranking. And then when you were at your final position, you would pull it out. Then the gunner would actually put the extension on this, load the ordnance, and then fire. Anyway, so yeah. Thank you for listening, and stay tuned for more content from the Kilted Filker Workshop. Stay tuned for more content from the Kilted Filker Workshop.